Hi there, this is Tuesday's notes. The main part of the notes that I want to go over is composition of functions. It's where you take two functions and combine them basically to make one function. You're going to compose a new function. We're going to use the functions f of x is equal to x plus 2, and then we'll use g of x is equal to 4 minus x squared. Now, there's some notation that you're probably not used to. If you remember function notation, if you're asked to find f of 3, then we would take 3 and plug that into x right there, and we would end up getting f of 3 equals 5. Okay, but we're going to do the same type deal, but we're going to do it with functions. So the notation that you're probably not used to looks like this. What this says is f of g of x. You can also write it like f of g of x. I'm going to write that out here. F of g of x. It's not fog of x, and this is not goff of x. That would be g of f of x. Now, right up here, when we found f of 3 is equal to 3 plus 2, the 3 on the inside there, that's your input. So here, the g function is on the inside, so that's the inner, which is your input. And then the f function is your outer, or your output. So what this says is that f of g of x says that we're going to plug the g function into the f function. So again, if you're asked to find f of g of x, that's the same as f of whatever our g function is, which is 4 minus x squared. So instead of x plus 2, we're going to take the 4 minus x squared and replace the x, or plug it into the x, and we get 4 minus x squared plus 2 instead of x plus 2. And then we can work that out, and we get a negative x squared plus 6. Let's go ahead and find g of f of x, which is the same as g of f of x. So really what it's asking for is g of x plus 2, because that's f of x. So we would plug x plus 2 into the g function, and we get 4 minus x plus 2. Let me raise that up a little bit. 4 minus x plus 2 squared. PEMDAS says that we have to square the x plus 2 first, then distribute the negative, and then combine like terms. And then the 4's will cancel out. That's composition of functions. Next, I'm going to flip this over. The next thing that I want to cover is called decomposition. Composition, we were taking two functions and composing a brand new function. Now we're going to start with one function, and we're going to break that down into two functions. An example might say something like this. Find two functions f and g such that f of g of x equals h of x. And then you'd be given h of x. So in this case, we're going to use 1 over x minus 2 squared. Find two functions, f and g, such that f of g of x is equal to h of x. So you're given h of x, and you're going to find f and g, the f function and the g function. Now, the g function is the input, and it's going to be plugged into the f function to get h of x. So, what I like to do, especially if I see parentheses, I like to start there and let that be my input. So I'm going to let g of x equal x minus 2. I would have to plug that into 1 over x squared to get 1 over x minus 2 squared. If I take this function and plug it into x right there, I get h of x. So your two answers would be the f function and the g function. Let's do one more. If h of x equals negative x squared plus 3 over 4 minus x squared. Well, by looking at this, I notice that I have something common in the numerator and the denominator. So what I'm going to do is let my g of x, because that's my input again, my g of x is negative x squared, and I would need to plug that into x plus 3 over 4 minus x squared. 4 plus x. So again, here's my input. I plug that into the x here, or replace that x with this, replace that x with this, and I would get h of x. So that is composition of functions as well as decomposition, and I hope that helps you if you happen to be absent.